2020 will be a banner year for the exploration of Mars. In addition to the launch of NASA's Mars 2020 rover, the European Space Agency and Roscosmos are sending the ExoMars rover to the Red Planet. As it descends from its landing platform, ExoMars will embark on an enterprising mission to uncover buried signs of past or present life. The Martian surface is a harsh environment, bombarded with cosmic radiation, but the subsurface could offer better protection. For this reason, ExoMars is equipped with an extending drill that can retrieve samples from up to 2 meters below the surface. Studying these samples will be the job of the Analytical Lab, a trio of instruments designed to search for the molecular fingerprints of life. The Mars Organic Molecule Analyzer, or MOMA, is the largest and most complex instrument on the rover. Its mass spectrometer subsystem and its main electronics were built and tested at NASA's Goddard Space Flight Center, which also contributed mass spectrometers to NASA's Curiosity rover and Maven orbiter. MOMA is designed with a mix of proven hardware and innovative new technologies. Here's how it works. In gas chromatograph mode, crushed Martian rock is put into an oven and heated to 900 degrees Celsius in just 2 minutes, vaporizing the sample. Molecules of hot gas rise up and flow into a narrow 20-meter-long tube. Special coatings inside the tube cause molecules with certain chemistries to slow down more than others, separating the mixture of molecules over time. Next, a beam of electrons ionizes the molecules, giving them a positive electric charge and deflecting them towards the linear ion trap. The ions are caught by a fluctuating electric field and sent to a detector to determine the chemical makeup. While gas chromatography has been used to study Mars since the Viking program, MOMA has a second method for preparing samples that has never been used on another planet. In laser desorption mode, a sample is placed beneath a powerful ultraviolet laser. A beam of energetic light builds within the laser and fires in a billionth of a second, concentrating its energy onto a spot smaller than a grain of sand. This rapidly vaporizes a portion of the sample, releasing large organic molecules that could be broken down by oven heating. The laser shot also ionizes some of the molecules, allowing the vapor to head directly to the linear ion trap. Neutral molecules are ejected by a vacuum, while the remaining ions are sent to the detector to determine their chemical makeup. Laser desorption will enable MOMA to detect long molecules, like lipids, the building blocks of cell membranes, a leap forward in the search for life on Mars. MOMA's linear ion trap is another first for the Red Planet. It will scan for the fingerprints of life using techniques normally confined to laboratories on Earth. One technique, called SWIFT, repeatedly ejects unwanted molecules from the trap. Over time, this builds up molecules of interest, improving detection. Another technique is tandem mass spectrometry, or MSMS, which identifies large molecules by breaking them apart and analyzing their fragments. By combining SWIFT and MSMS, MOMA can determine an individual molecule's formula and its structure, both important criteria in the search for life. The question of life on Mars is among the most important in planetary science, and the evidence may be buried just below the surface. With the help of MOMA, ExoMars will take us one step closer to uncovering the answer.
In 2014, NASA sent its Global Hawk aircraft out over the ocean to study Hurricane Edouard. This remotely piloted vehicle collects data like temperature, relative humidity, and wind speed to better understand how hurricanes intensify. Sometimes clouds block the measurements taken directly below the aircraft, so the scientists drop individual instruments that parachute down to the surface. These dropsondes also measure the wind speed and direction as they fall. Near the surface, especially in the center of the storm, the deep red to orange color indicates there is plenty of moisture for the storm to draw on to intensify. The result is a well-defined circulation of winds, which are strongest near the storm's center. During Hurricane Edouard, dry air near the center slowed intensification. But then, just before a period of rapid intensification, clouds and precipitation moved into the dry region, bringing moisture. Did the movement of moisture cause the rapid intensification, or did the stronger winds at the onset of intensification cause the clouds and precipitation to move? Studies like this one will help us learn that answer.
Throughout the universe, there are forces fundamental to how things move. Just as gravity is key to how things move on Earth, a process called magnetic reconnection is key to how charged particles speed through space. The more we understand how those particles are accelerated, the better we can protect our spacecraft and astronauts as we explore deeper into the solar system. And now, NASA's Magnetospheric Multiscale Spacecraft, or MMS, has discovered magnetic reconnection occurring in a new and surprising way near Earth. Typically, images of our planet from space show a blue-green sphere engulfed by the darkness of space. But invisible to the eye, a vast network of magnetic energy and particles surround our planet. Earth's magnetic field creates a protective bubble that shields us from highly energetic particles that stream in both from the sun and interstellar space. As the solar wind bathes our planet, Earth's magnetic field lines absorbs this energy and gets stretched. And like elastic bands, they eventually release energy by snapping. As a result, particles in the region are flung at supersonic speeds. That burst of energy is magnetic reconnection. It's pervasive in the universe. It happens on the sun, around Earth, and flings particles across the solar system. Scientists have observed this phenomenon many times in the magnetosphere, Earth's vast magnetic environment. Now in a new study, MMS caught the process occurring in a new region. For the first time, magnetic reconnection was detected in the turbulent magnetosheath, the boundary between the magnetosphere and solar wind. This region is made up of turbulent plasma. It's one of the most chaotic regions in the near-Earth space. MMS captured 3D observations by flying 4 identical spacecraft in a tight pyramid formation through the magnetosheath. These arrows show the hundreds of observations MMS took to measure the changes in particles and the magnetic field. This is the moment MMS sees bursts of energy from magnetic reconnection. But these signatures don't look like standard reconnection. Compared to standard reconnection that occurs over tens of thousands of miles, this new magnetic reconnection spans only a couple of miles within turbulent plasma. These reactions are essentially much smaller but more stretchy elastic bands that accelerate particles 40 times faster. In short, MMS spotted a completely new magnetic mechanism that's much quicker than we've seen before. Just like when you mix milk into coffee, turbulent plasma in space moves randomly and creates vortices. It can transport particles and energy, but a lot is unknown about how these particles move through these regions. Showing that this new magnetic reconnection plays a role in turbulent plasma gives scientists insights into how turbulence influences particles moving through space. By looking at such fundamental processes in space at both large and small scales, scientists can learn what drives the complex environments we travel through to explore our solar system and beyond.
Hi, I'm Amanda DeBelly-Shower. I'm an undergraduate student right now at Old Dominion University, and I helped work with Bob, the tick-killing robot, last summer here at NASA Langley, and we actually protected the CDC, the Child Development Center, from ticks.
My name is Lexi White. I'm a PhD student with the ODU Tick Research Lab.
A tick-bot is a tick-killing robot. It's semi-autonomous and follows a predetermined outline perimeter that you lay out. And it can actually protect an area, providing immediate relief from tick encounters for 24 hours.
This is Mission Control. National Symphony Orchestra, you have permission to launch. 10, 9, 8, 7, 6, 5, 4,
NASA has blazed a trail, and it has transformed all of our lives by blazing that trail. The way we communicate, the way we navigate, the way we produce food, the way we produce energy, the way we predict weather and understand the Earth. All of these capabilities that, in many cases, these capabilities we take for granted as Americans, are available to us because of the trail that NASA blazed.
A lot of the technology that we have today that a lot of us take for granted wouldn't have been possible if it wasn't for a lot of NASA's work. A lot of the systems that we use today in our cell phones, if it wasn't for a lot of that R&D that NASA was doing back then, we wouldn't have what we have today. So whether you're exploring space or just trying to solve problems, technical problems, NASA has done a lot of that heavy lifting for a lot of us.
I was going to be a part of this celebration for NASA's 60th anniversary no matter what, because I mean, I grew up loving NASA.
NASA called me, and whenever NASA calls me, I say yes.
To me, it seems kind of obvious. I think space exploration and science is something that deeply inspires everybody.
In a world filled with bad things, NASA was doing things for good. And I always loved that about it.
I'm just a huge fan of NASA in general. I think it's the missions that are happening, have happened and continue to happen are a kind of poetry that is the most moving thing we have right now, this sort of age of exploration.
The ideals of NASA, peace, exploration, science, courage, these are ideals that we want to celebrate.
In the next 6 years, I see NASA experiencing an explosion of creativity from the young people.
I would love to see them go to Mars. I would love to see a person walk on Mars. I think that would be amazing, because when you talk to anyone in the world who was around when they landed on the moon, the thing you hear that is the common thread is the world stopped. Everyone just came to a complete standstill for one moment to realize that we're all just this one blue planet.
I want us all together to also look to the future, because we have a plan to send humans back to the moon and then onto Mars. We have the most amazing rocket designers on the planet building the systems right now that are going to take humans farther into the solar system than ever before.
Scott and I heard it was your birthday, so we thought we'd sing you a little song. Ready? 3, 2, 1. Happy birthday to you.
Hi, I'm wishing NASA a very happy 60th anniversary.
Happy 60th anniversary.
Happy 60th anniversary to NASA.
I want to wish you a happy birthday.
Happy 60th anniversary, and thank you for all of the endless inspiration you've given me over the years.
Happy birthday, NASA.
Tonight it's my pleasure to share with you the official logo that will be used to observe these milestone anniversaries.
We have a unique tool that allows us to print at a much faster rate.
From genetic engineering, 3D printing, or a combination of them will achieve our goal.
Rather than using animal model, 3D bioprinted approach will be advantageous.
Our team has developed a bioreactor for the dynamic culture of refusible engineered vascular networks.
The core insight of our technology is that we're using holographic laser projection. This printing process decouples resolution from from speed in a unique way that will allow us to build full human organs in a matter of hours.
We have a very comprehensive approach to the problem, which leads to more innovative and original solutions.
It's all about matters of the heart. Hi, I'm NASA astronaut Tracy Dyson. Welcome to Station Life. The focus of today's show is on matters of the heart as they relate to good cardiovascular health. We'll take a look at how NASA keeps astronauts' hearts healthy off the Earth. And we'll take a look at some of the research being done aboard the International Space Station that can keep all of us healthier here on the Earth.
Houston on 2 for velocity confirmation. Go ahead, leave steps 4, 5, and 4, 6. We're moving on to step 5.
You want to go right now for that activity?
Copy. Thank you.
Okay, Tracy, we copy, and that's good information. We'll pass it along.
Cardiovascular disease, including heart disease, stroke, and high blood pressure, is the #1 killer of men and women across America. Fortunately, many studies have shown that healthy habits, including good nutrition and exercise, are important for maintaining a healthy heart here on Earth. Those habits are even more important for astronauts on the International Space Station. Living in microgravity for 6 months changes our bodies in a number of ways. Without gravity, we lose bone mineral density, our muscles atrophy, and our cardiovascular system gets weaker. Some of our studies have shown that in space, the size and shape of our hearts may actually change, which could make it difficult to do our jobs when we get back to Earth or even land on Mars. On Earth, our heart and blood vessels are well adapted to work against the downward pull of gravity. In space, however, there's a tendency for blood and other bodily fluids to accumulate in the upper body. Let's take a look at one of the consequences of this fluid shift.
We have recently identified that some astronauts experience changes in their vision, which might be related to the cardiovascular system. Our hearts pump blood around our body through blood vessels. Special adaptations in our bodies ensure that fluid is evenly distributed despite the pull of gravity. In space, astronauts no longer experience the downward pull of gravity, and the fluid in their bodies tends to move towards the upper body and the head. Our cranium is a rigid container. As the fluid moves towards the head, it causes the pressure inside the skull to rise. This is known as increased intracranial pressure. The optic nerve travels from the brain to the eye. The increased pressure from the cranium travels down the nerve and affects the eye. It causes the optic nerve to be squeezed, and the optic disc, where the optic nerve meets the eye, to swell. The back of the eyeball flattens as pressure builds behind it, and the blood vessels in the back of the eyeball also swell. These changes can affect the astronaut's vision. One change is that the astronauts become farsighted. A second change is that they can develop cotton wool spots, which represent damage of the nerve fibers in the back of the eye. These can cause discrete areas of vision loss. NASA is working to understand and prevent these changes in astronauts, which may also help us understand and prevent related vision changes here on Earth.
One of the tools we have to study heart health aboard the space station is an ultrasound device, which uses harmless sound waves to take images of the inside of our bodies. Those images can be viewed at the same time by researchers and doctors in mission control. With minimal training on the ultrasound, remote guidance techniques developed by NASA enabled astronauts to take detailed images of their own heart. In our next segment, we'll travel to a small community in Brazil that has benefited from remote medicine techniques that were advanced by the research aboard the International Space Station.
Minas Gerais is a large state. Our territory is about the size of France, and we consist of 853 units and municipalities. There are large distances between our communities and many very isolated rural communities.
Nós estamos utilizando a nova
In the ambulance, we can use ultrasound in various situations. In those situations where time really matters, in which you have little time to make decisions. The idea of using ultrasound for healthcare is like an extension of the physical examination. You are able to conduct the exam with much more detail. And you can use it at the time to make a decision, or you can use telemedicine platforms to obtain a second opinion from someone at a distance.
Temos uma barreira geográfica que é o Rio São Francisco.
We have a geographical barrier that is the São Francisco River, which is both a blessing for the region, but it also isolates us.
Nós vivemos numa região em que os
We live in a region where financial resources are few. People do not have a lot of work, but they are honest, good people who do not have much opportunity. So there are many needy people who need these resources and rely only on this institution to provide assistance.
E uma tecnologia dessa que vem.
This is a technology that helps us solve many problems.
Que teve caso de uma paciente que estava com insuficiência respiratória grave.
That was the case of a patient who came to the hospital with severe respiratory failure, and the people realized she would die in just 20 to 30 minutes. We talked with Dr. Parzelli, who was training us to use the ultrasound. He came and applied the ultrasound and discovered large amounts of fluid around her lungs and heart. We performed the procedure and drained a lot of fluids. In 20 minutes, 10 minutes, the woman immediately experienced an improvement and in half an hour was already walking. It was like a miracle, a rise and walk. She was dying in front of us without people knowing what was happening. This ultrasound was instrumental in saving the life of that patient.
All right, ladies and gentlemen, boys and girls, space geeks from all over the world, we have with us today a real treat. Dr. Koichi Wakata from the Japanese Space Agency and absolutely one of my favorite astronauts. Actually, in fact, wait a minute. I have a list right here, and I want to prove it. Look, Koichi.
Oh, great note.
TC's Top 10 Heroes of Space Travel. Look.
Wow!
He's on there. Welcome, Koichi.
Good to see you, Tracy, here.
Nice to see you, too. Thank you for joining us on Station Life.
My pleasure. I'm always watching your program.
Really?
I'm glad to be here.
Oh, wow. Did you hear that? I am so excited that I'm actually honored that you watch our show. It's all about the space station, you know.
Yes. Yes, this is wonderful to be able to explain how wonderful it is to work and live on board the space station.
Yes.
And then today, what are we talking about?
Today we're talking about cardiovascular health.
Awesome.
Yes. And you know a thing or two about that.
Yes, we do exercise pretty much every day.
Yeah. I was going to ask you on board, did you work out every single day?
I did, because it's not only, to keep, my body healthy, but also it's a very important psychological, I think, relaxation for me. And then the best part of the exercise is the what is that? The ARID device that we have on board.
Yeah.
It's just sitting right next to the cupola windows. Yes. It's probably the best view gym in the entire world.
Absolutely.
I think. Yeah, you can do the muscle strengthening exercise, and at the same time you can see this beautiful home planet, and what a wonderful place.
That's right, because we have the cupola and we have that big center window, we call it window 7, and then most days, because the space station is oriented with the belly of the space station facing the Earth, which means that the cupola windows are facing the Earth, and there we are on the ARID, above it, below, however you want, whatever your perspective is. But anyways, we're right in line looking out that window.
which seems to us like we're on a bench, we're doing our bench press, and we're looking out that window. And I remember doing my exercise one day, and I saw red soil go by, and I'm like, that's Australia!
Exactly.
So yes. You can practice geography at the same time. Can you tell us a little bit about Sprint and what that was all about?
Right, Sprint exercise is a new protocol, and already several astronauts have tried that method. And basically, it uses the prescription of like a higher intensity of exercise, but less volume or less number of exercise days. For example, like if I on board the space station 7 years ago, I pretty much exercised like running for 40 minutes in the same pace. But here, as far as cardiovascular is concerned, we have like a sprint running, like for 30 seconds sprint, and 15 seconds rest, another 30 seconds of run. But it's only like 6 or 7 minutes, very short interval, but high intensity training. And you do that like 3 times a week instead of 7 days a week. Wow. And so it's like a smaller number of days of exercise, but the higher intensity. And that's part of the sprint protocol. So 7 years ago when I was on board the space station, I used the previous protocol, which I exercise every day. But this time, it's a smaller amount of time actually. But the results were pretty good. I was able to walk right after landing, and so I think this new protocol is working very well.
Wow, so if you compared when you were on board and landed 7 years ago to now, when you did this new protocol and you exercised more and you had probably more emphasis on the exercise because you have more equipment to work with.
Right.
A big difference, did you notice?
As for after landing, I don't see very much difference. So that means that's such a very efficient way to do exercise, because if the results are the same, if you spend less time and exercise, that means it's a very efficient way of exercising. So maybe we can utilize that in the future when we go to beyond low Earth orbit, when we go to Mars, and then so a lot of new protocols are being tested on board the station.
Yeah, and I can see where folks back here at home who don't have time to exercise pay attention to this, because you can spend less time working out and get the same benefits as if you were working out for 2 hours or something.
Right.
And you have done just a tremendous amount of work, Koichi, not just in your most recent increment, but throughout your career in the space program, and you've been an asset to Japan and to NASA and to the International Space Station and to station life. So thank you so much for being here with us, spending so much time sharing your stories. We've just had a lot of fun with you. So wish you all the best as we go forward. I'll see you, probably in 5 minutes. But, thank you so much for being here with us.
I enjoyed it. Thank you, Tracy.
Likewise.
Glad to be here.
Cool.
Just curious. I think they can access the ice in here. Yeah, it depends on how much water pressure we have that day. We can do 16 to any of them at pretty much any time. If we have good water pressure, we can get you up to around 80. But you're saying Tracy's taking all the phone. No, you're the one after Okay. Thank you for that.
So with all this exercise going on, is it really working? Researchers and ACERs, who are astronaut strength conditioning and rehabilitation specialists, have made great progress. Before we had a full gym on the space station, our astronauts needed quite a bit of recovery time back here on Earth. Today, our astronauts are coming home in excellent health.
My name is Mark Williams. I'm the lead astronaut strength and conditioning coach. On board at the International Space Station, we have 3 pieces of hardware. We have a cycle, which we call CVIS. We have a treadmill, which is called T2, and we have a resistive exercise device, which is called ARED. And each device is specifically designed to do certain things for the astronaut. We try to do one of those particular devices every other day. One of them we're going to get a little bit better cardiovascular fitness out of it. The other one we get a little bit more impact loading, like running on the ground. So that affects muscle, it'll affect a little bit of bone, does things. Those are the physiological aspects of it. But then also making sure when they come home from a 6-month flight that they don't come home like a bowl of jello. You know, they're going to lose muscle, they're going to lose strength, they're going to lose bone, they're going to lose cardiovascular fitness. But at the same time, then we have to take them, get them back to where they were before they left, which is what we do in our post-flight period once they come home for about 6 to 8 weeks, and just get them prepared back to normal life, you know, doing their job, doing with their family, doing yard work, whatever that happens to be.
Have you ever been sedentary for a long period of time, like lying in bed for a week because of an illness or surgery, and then stood up quickly? Did you feel like you might fall or that not all your senses were functioning? Hi, I'm Dr. John Charles with NASA's Human Research Program. During the one-year International Space Station mission, NASA will conduct functional studies to gain insight into key physiological factors that contribute to changes in performance. Just like it would take minutes, hours, or even days for your body to acclimate to standing after lying in bed for weeks, it takes time for an astronaut's body to acclimate to an environment with gravity after working without it for many months. 2 tests will focus on post-flight tasks and procedures that will be vital for an exploration crew that has just landed on a planet after a prolonged period of weightlessness. The functional studies will assess how the neurosensory networks, eye-hand coordination, fluid distribution, cardiovascular, and skeletal muscle performance all work together to accomplish an integrated task or function. Researchers hope to compile a post-flight recovery timeline and develop and validate tests to define acceptable performance and define the linkage between physiological changes and functional capacity. This information will be helpful for astronauts and researchers as they prepare for future long-duration missions to asteroids, Mars, and beyond. To learn more about NASA's Human Research Program, visit www.nasa.gov.
So now let's hear from one of our researchers who is studying the cardiovascular system off the Earth for the Earth.
My name is Stuart Lee. I'm the lead research scientist in the Cardiovascular and Vision Laboratory at Johnson Space Center. So the astronauts in spaceflight is somewhat analogous to if you took one of us on the ground and told us not to exercise for a long period of time. So spaceflight has allowed us to see the deconditioning effects, and we can see all the negative things that can happen when you don't exercise, when you don't do physical work every day that we're actually genetically designed to do. So I would say that cardiovascular health is important from the aspect of the heart and the blood vessels are the communication system in your body. So the experiment that they're demonstrating in the background is the primary measurements in our cardiovascular experiment called CardioOx. And it's primarily looking at the health and function of the arteries in your body. In this particular case, they're scanning the brachial artery, and we use that as a surrogate for the arteries in your heart, the coronary arteries. So we're able to see how they would respond to stress. And obviously, if they respond well, then we've got good cardiovascular health, and it has a good prognosis long-term for the health of the heart. So they're looking specifically at how the vessel expands and contracts with each heartbeat, and then we stress the vessel and we see how well it expands. And those are key functions in your ability to adapt to stress when you're exercising or when you're experiencing orthostatic or gravitational stress. And so it gives us a way that we can look at throughout the mission and after the mission how the crew members are responding to the spaceflight experience. So CardioOx is looking primarily at the health and fitness, as you might say, of the arteries. The unique part of CardioOx is we're actually looking at 5 years after the mission. So most experiments just look some in and post-flight. We're actually interested in long-term health of the crew members 5 years later, where their stress is involved with spaceflight, which might have caused some issues for them. SPRINT is another experiment that looks at cardiovascular, but it looks primarily at the cardiovascular fitness end of things, how hard you can work. We call it VO2 max or maximal oxygen consumption. How hard you can get your body to work during space. And VO2 max test is very good because it's an integrative test of the cardiovascular system. It brings together all the function of the cardiovascular system so you can work as hard as possible. So these experiments together give us an idea of what's happening on the functional side of things, the SPRINT study, and then on the I don't want to say pathological, but on the health side of things with CardioOx. And then with the CardioOx twins experiment, we're also then looking at how genetics affects those things. My name is Stuart Lee. I'm a lead research scientist in the Cardiovascular and Vision Laboratory at Johnson Space Center. We're working off the Earth for the Earth.
International Space Station provides an unprecedented research platform in space, allowing doctors and scientists to conduct science experiments that can't be done anywhere else. For NASA, keeping our astronauts' heart healthy is vital for continuing the journey off the Earth. Here on the Earth, the keys to good heart health are good nutrition and vigorous exercise. Thanks for joining us on Station Life at our behind-the-scenes look at cardiovascular research being done aboard the International Space Station. And as always, be sure to follow us on Facebook and Twitter for the latest research news, and download our app, which is legit, on your mobile device. Until next time, we're working off the Earth